jumping into a little bit more deeper of an application with systems, and we're going to solve word problems with systems. 3 things to do. The first thing you need to do is define your variables. That means let x equal something and y equal something. They're not going to tell you x and y. You're going to have to define it. Like let x equal girls, y equals boys. Let x equal a big number, y equal the small number. Let x equal giraffes, y equal elephants, okay? You're going to have to define the variables. So you should have this written down on your notes. When I say define, it means you have an x equals something and a y. Then you're going to make 2 equations. Box that off. Because remember, you want to line things up and cancel out. So you need 2 equations. And then solve. That's what I mean. What is the point? All right, let's apply this right away. So the larger of 2 numbers is 11 more than twice the smaller. The sum of the numbers is 1 less than 7 times the smaller. Find the numbers. I'm already confused, I bet you are too. I'm going to reread one more time. The larger of 2 numbers is 11 more than twice the smaller. Okay, I'm doing that underline strategy. That's a fact I need to know. The sum of the numbers is 1 less than 7 times the smaller. Find the numbers. Step 1, define the variable. X equals the big number, y is the small. That's my step 1. So I know, okay, x is my big number, y is my small number. Now I have 2 equations. The larger x of the 2 numbers is, so that's x. X is 11 more than twice the smaller. So 2 times the smaller plus 11. Y was my small. I already can tell I'm going to use substitution because I see a variable by itself. The sum of the numbers is 1 less than 7 times the smaller. Sum means add. So x plus y equals the sum of the numbers, that means the big plus the small, is 1 less than 7 times the smaller. So 7 times the smaller, take away 1. Holy moly, this is intense. That's okay though. I see that I have a variable all by itself. That's when I use that parenthesis strategy. Substitute. And I see a lot more success with substitution than I do with that elimination strategy. So x got the substitute. That means I put this in x's spot. So 2y plus 11, that's my x, plus y equals 7y minus 1. And now I solve. And that's where you have to know your algebra skills. So 2y and 1y is 3. 3y plus 11 equals 7y minus 1. Move this 7y over here. Subtract 7y. That gives you negative 4y plus 11 equals negative 1. So I'm going to minus 11. Negative 4y equals negative 12. Y is 3. Oofta, not done though. Not done, but at least here's what I love about substitution. At least substitution is always easier to plug back in. So this goes back to my parentheses, and you go 2 times 3 plus 11 which is 17. So my big number is 17, my small number is 3. Okay, that's lovely, but that's not really real life situation, right? I mean, that's just a numerical situation, which you don't really have any connection to that real life. Okay, so the next one is related to carnivals. It says the cost of admission to the spring carnival is $39 for a group of 8 kids and 3 adults. The admission was $43 for another group that had 11 kids and 2 adults. What's the admission price for a kid and an adult? So I have 2 people that I'm talking about. I have adults and kids. So step 1 says define your variable. I'm going to let x equal, what do you want, kids or adult? Adult. X is the adult, y is the kid. Okay? So the cost of admission to the carnival, here's my first equation. This is first equation. Was $39 for a group of 8 kids and 3 adults. So 3 adults plus 8 kids was equal to a grand total of $39. You see how I wrote that equation? I said 3x, that means 3 times the adult, plus 8y, which is 8 times the kid, equals a grand total of $39. My next equation, $43 for a group of 11 kids and 2 adults. So 2 adults plus 11 kids equals $43. Now this is where you're going to want to make sure that you have your calculator ready to go. Alright, so now see how they're lined up? Since they're lined up like this, I'm going to do elimination. So I don't have to substitute. So what I need to do is make one the opposite of the other, and it's going to take some time. So times through by -2, times through by 3. Distribute, and I get -6x plus -16y equals 39. Now this is where I'm using my calculator. 39 times -2 is -78. And now my bottom, positive 6x plus 33y equals 43 times 3, 129. And boy, I'm going to use my calculator again, because I don't want to make a sign error. That's the worst thing you can do. So this cancels. Now I need to know -16 plus 33. So I'm putting that in my calculator. -16 plus 33 is 17y. Now I need to know -78 plus 129. 51. Divide. Y is 3. So what was y? Now this is real life. Y was a kid. So that means I have $3 for a kid. Now I need to know how much for an adult. So that's when I plug back into one of the equations. So this 3 is going to go right there. And I'm going to get 3x plus 24 equals 39. I got 24 because I brought the 3 to the y. 8 times 3 is 24. That's where I got that. Subtract 24, or 39 minus 24 is 15. 3x is 15, x is 5. So that x was the adult, so $5 for the adult. Okay, you might be like, oh, whoop-de-doo, carnival situations, no biggie. I do have more situations that are more relatable to you in the test, and your worksheet today. I have like Converse sales for a shoe company, and I have like American Eagle pants, skinny or boot cut style pants. Salespeople have to use this if you do analysts for a company because they want to maximize their money. They're going to try to figure out how many skinny jeans do we want to sell, how many low tops or high tops do we want to sell. Okay, so it is very real life applicable. But let's change it to this math teacher one, and it's the last one we're going to do. So let's say a group of kids take their math teacher out for lunch. Yep, kind of creepy, will never happen, but just pretend. Okay? If 5 hamburgers and 4 hot dogs, the bill is $19.50. If we have 4 hamburgers and 5 hot dogs, the bill is $18.75. What's the price of a hamburger? So I have 2 situations, X and Y. What do I want X to equal?
Hamburger.
Sure. X is hamburger. What's Y equal then? Huh? Hot dog. I think we should flip it though. Because if you, our strategy, X cancels out, so you don't have an X equals something. So I think we should have hot dogs be the X and hamburger be the Y. Because otherwise, we're canceling out hamburger and we're going to have to go all the way through the whole process to plug it back in. So make X the hot dog, Y the hamburger. And Y is the burger. Okay, so group of kids, let's see, 5 hamburgers and 4 hot dogs for $19.50. So 4 hot dogs plus 5 hamburgers was $19.50. Four hamburgers and 5 hot dogs is $18.75. So X is the hot dog, and I have 5. 5 hot dogs plus 4 burgers was $18.75. How much for the burger? What's going on? Now they're lined up and we're ready to use elimination, and it's going to take forever because you got big numbers involved with decimals. Calc it out. So I'm going to times this by -5 and the bottom by 4. So then it's -20x plus -25y equals something probably ginormous. 19.5 times -5, -97.50. 20x plus 16y equals 18.75 times 4, $75. I know, trust me, there's going to be things where you're going to get negatives involved. They usually cancel out at the end. And that's what I see is going to happen here. Because you can't get a negative a hot dog or a burger. Okay? But just trust the process. -25 plus 16 is -9y. -97.5 plus 75 is -2250. Divide, and you get a +250. So y equals a +250. What was y? Y was my burger. Okay? So it was $2.50 a burger. And I don't have to plug back in there.